Hello guys, good evening. So today we'll be looking at the differentiation by chain rule. Differentiation using chain rule. Because the chain rule is also called the function of function. But another name for chain rule is function of function. And this is called so just because we apply the chain rule whenever we have the function of function. Function of function simply means composition of function. Function of function means composition of function. That is, when one function is imputed into another function. Let's take an example. Say we have a function g of x to be equal to sine x. So if we have a function g of x equals sine x, and we have another function f of x to be 2x, then if I am to solve g composite f, g composite f simply means wherever you find x in g, you replace with f. Wherever you find x in g, you replace with f. So to solve this, we would have sine, in place of the x here we have what? 2x. So our new function is, which is g of f is equal to sine 2x. So we may call this a new function, say y. So looking at this function, you discover that this new function was obtained by imputing 2x into sine x. So what it simply means is that whenever you find this kind of functions, you apply the chain rule, because this is called a function of function. So the method I'll be differentiating these functions. I'll be differentiating various functions without having to use the formula. I'll be teaching you how to tackle it directly without having to apply the formula. Then before that, the formula for the chain rule is the y, the x equals the y, the u dot the u, the x, from which you notice that the u can cancel out the u, and then we return back to the y, the x. So this is the formula for chain rule. I'll be solving a lot of problems in this rule without using the formula, so that you see I'll be teaching you a very fast approach to it because of your exams. So now, looking at this function, the simple rule in solving the function of function is your ability to identify the inner function. And looking at this, we discover that the inner function here is 2x. So for chain rule, you start differentiating from the inner function. So for chain rule, you notice that the method is differentiate from inner function. So for chain rule, we simply differentiate from inner function to the outer function. So that's the simple thing we do there. Differentiate from inside to outside. Now, if we have y equals sine 2x, and we are to differentiate this, the simple thing we do, we identify the inner function. The inner function in this is 2x. So we differentiate from inside. Now, if I differentiate 2x, I will get what? So y prime, if I differentiate 2x, I would obtain 2. And if I differentiate the outer function, if I differentiate sine function, I will get a cosine. So then we rewrite the inner function. So this is the derivative of that function. So that is very simple. I'll take another example. If I have a function, say y equals exponential 2x. Now, looking at this, you discover that the exponential function should not have a constant attached to it. So for us to have exponential 2x simply means that there is an inner function here, and looking at that, the inner function is 2x. So in the same way, we differentiate from the inside to the outside. So when I differentiate 2x, I would obtain, so y prime is, when I differentiate 2x, I would obtain 2. When I differentiate exponential, I will obtain exponential. Then I will rewrite the inner function, which is 2x. So the first derivative of y equals exponential 2x is 2 exponential 2x. So now we'll be looking at another function. Now let's say we have a function y equals exponential lim cos 2x. So we have a function y equals exponential lim cos 2x. Now looking at this function, it is not a difficult function to differentiate. All you need is the concept of logarithm. Now if you recall, I want you to note that when you have a function, when you have a log function like this, log to base a of any number b. Now note that when you have, you notice that a and a are the same, so the base of the log is same with what you have here. So whenever you have something like this, be it e, notice that it should be e and e. So whenever you have something like this same thing as b, so this is the same as b. So looking at that, using that concept, you'd notice that y would reduce to a simpler function. You notice that y will become cos 2x. So y becomes cos 2x. And differentiating this, the inner function, so y prime, the inner function here is going to be 2x. So when we differentiate 2x, we get 2. Now when we differentiate cos, we get minus sign. Then we rewrite the inner function 2x. So this gives us our answer. So I would stop here. In our next video, we'll treat more complex functions. Thanks for watching. Make sure you subscribe and like the video. Thank you.